I'm going to add some details that are not in the book, which I have done in each chapter based on my own research and thinking, just to give you a broader perspective than just following the book. So what is we talked about social cost of carbon, each additional ton of carbon and how it benefits or costs every part of the system you are living in, from buying, eating, traveling, health, etc. Right? So what is the role of emissions in this sense? So economists use integrated assessment models, we looked at that briefly, to calculate an optimal carbon tax rate. This is from a nice article in Scientific American on how to tax carbon that you can look at. I didn't put the link because this figure they themselves take from Jen Christensen, which may be a reporter for them. Anyways, the models calculate feedbacks between the climate and economy by characterizing the economy and worldwide cycling of emissions arising from economic activity and damages to the economy from atmospheric and upper ocean temperature increases. The experts also factor in uncertainties. We talked about integrated assessment models and mentioned that they are used in creating these representative concentration pathways, and there is an iteration between integrated assessment models and Earth system models, because integrated assessment models take input of climate from Earth system models, which do the very detailed climate, and Earth system and the integrated assessment models then feed back the emissions that would result from the various socioeconomic pathways in the scenarios, for example. Okay. Here are the uncertainties in terms of catastrophes, uncertainties in terms of damages. So that's the integrated assessment model. There's the Earth's carbon cycle included as a simple module, ecosystem damage, and there is the model economy. And here is where the emissions come in. Emissions reductions, input output go between model ecosystem damage and economy, which then feeds back to the carbon cycle, which then affects the climate change and ecosystem damage. Okay, so together they should impact policy response set as a carbon tax rate. Well, not always, but this is what this example is showing. And then there is the discount rate that we talked about. Remember, the investments we make now based on the policy choices can only be evaluated in terms of the current discounted value of the investment from certain period into the future. After 25 years with the discount rate, what is the value of the investment we are making, and so on. Okay, so that's the context of emission reduction. But what is happening around the world? Before we go into the details, since the chapter insists that carbon tax is one of the best ways to do policies for incentivizing emission reduction, here comes my favorite chopper again. This is a chart from the same article from Scientific American, but it's from a World Bank group. So I will wait and look at the lake, the birds, and the artificial bird, the chopper going by. Okay. So this is called a crazy quilt of carbon taxes, showing the tax rate in 2019 in dollars per metric ton, the median value. The country is represented there in terms of the emissions portion covered by the taxes, and the revenues they got in 2019 in millions of US dollars as a median value. So 24 countries have enacted carbon taxes, with rates ranging widely from $0.08 in Poland to $121 in Sweden. Sweden, a rich, progressive country, is doing a lot of climate things, including plans to go completely renewable and so on. And the leading models suggest a tax of $40 to $47 in the US, but the country has not implemented any plan as of 2019. Okay, there is the big gorilla in the room. Okay, so just look at the incomes. France has a huge medium revenue from carbon taxes with a carbon rate of almost 49.23 million value per ton of carbon. And Sweden is doing pretty well with a much bigger carbon taxation. Switzerland, Liechtenstein, Finland, so small rich countries, Norway, British Columbia we will talk about in a little bit of detail, country of Colombia, Estonia, and so on. So the range of countries is interesting, going from middle to low income countries to very rich high income countries with small population versus large population, and so on. Is China in here? Chile, Portugal, Spain, Iceland, don't see China. Okay, Japan is in there. Anyways, the bad news, just like when we talked about the Paris Agreement and the negotiations, which have gone on for 25 years, but the emissions have shown no sign of slowing down. The fuel efficiency, comparing different countries in different years, going from 2005 to 2017. The bad news is that pretty much everywhere the fuel efficiency standards, especially considering light duty vehicles increasing in number, light duty vehicles include SUVs, passenger cars, sedans, trucks, utility trucks, and so on, which have a big footprint. Size is big. Their fuel efficiency is typically lower compared to a small car, obviously compared to hybrid car, for example. Everywhere, the liters of gallon equivalent per 100 kilometers have gone up. Well, they have gone down over time. That's the good news. But is that enough? So amount of gasoline being consumed by per 100 kilometer is gone down. But the trick, as we will see, is that as incomes go up, people buy more light duty vehicles or bigger cars, SUVs, etc., instead of smaller, more fuel efficient cars. So how do you incentivize those? The good news in the US, as you know, Trump administration tried to dismantle Obama's ambitious fuel efficiency goals. If you know the story, you know where that goes. But automakers, on the other hand, have rejected that effort to do away with fuel efficiency standards. We will see details of that, and they are actually together wrote a letter to the president's appropriate office, to him directly actually, in 2019. This article is from 2019, asking that they need a uniform fuel efficiency standard, especially including California, because California has a waiver, as you remember, can negotiate its own standards, etc. So manufacturers themselves, especially after the lessons they learned in 2008, bankruptcies, bailouts in the US, and the difficulty of keeping up with the Japanese manufacturers in terms of improving fuel efficiency standards. They are saying we don't want to weaken the fuel efficiency standards, and we don't want to have state-based efficiency standards, vehicle-based efficiency standards, but make them uniform, and have California be part of the agreement as well. Okay, because manufacturing process and their own efforts to reduce carbon emissions will become much more pipelined and easier, cost effective, by making them uniform. Good idea, right? So corporations themselves are becoming more aware of the need to supply a market that's headed towards electric vehicles more and more. So the research in internal combustion engines still happens till they are phased out, they want to be fuel efficient.